Whenever you have a leading coefficient other than 1, a technique that you can use would be to divide both sides of the equation by whatever that leading coefficient is. All right. But the thing about a fraction is when you divide by a fraction, that's the same as multiplying by the reciprocal. All right. So you can, in this case, divide each term by 1/2. All right. But that's going to be the same as taking that original equation, 1/2 r squared minus 6r equals 2, and multiplying the whole thing, both sides, by 2. All right, so if I just pop this set of parentheses around both sides and multiplied by 2, I would get the same thing. All right. So, and I'll just do it both ways, you'll see. All right, divide anything by itself, the result is equal to 1, so r squared. When you divide by a fraction, it's keep, change, flip. So this is really the same, this little guy here is the same as 6 times 2. 6 divided by 1/2 is the same as 6 times 2. All right, keep, change, flip. If you're ever unsure about something like that, chuck it into a calculator just to play it safe. But that's going to be minus 12r equals, and same deal here for that last one, keep, change, flip, 2 times 2 is going to give you a 4. All right, so now it's actually tailor-made for completing the square. All right, the constant term is over on the right-hand side all by itself, so I don't even have to move it out. Right? So what I'll do is I'll just leave a little blank so I can complete the square, then I'll do my side work. Oop, that jumped on me. All right, but if I use the other approach, I would be distributing the 2 to each term within the parentheses. 2 times 1/2 would be 1, so that would give me an r squared. 2 times -6 would give me a -12, so -12r, and then 2 times 2 would give me a 4. So you see you get the same result. All right? So whichever method you like is going to work, as long as, I mentioned this before, you can multiply or divide both sides of an equation by whatever you want, as long as it's not 0, and as long as you do it to every term on both sides. All right? So for my side work here, I would take my b value, and hopefully after, I mean, we've done a fair amount of practice with completing a square by now. Hopefully we're moving closer and closer to being able to do this step in your heads. All right? But if not, we do our side work. We take that b value, -12, we chop it in half and square it. So that's the same as -6 squared, which is 36. All right. Whenever you take a positive or a negative number and square it, the result is always going to be positive. All right. So if you ever run through this computation and come up with something negative, it usually means you put it in the calculator wrong. All right. It happens fairly frequently, so it's definitely worth talking about it. I'm going to give that a second to open up. But if you want to put a value squared in a calculator and that value is negative, you got to put that value in parentheses. Otherwise, the calculator is going to think you're trying to do something else. All right, so 3, 2, 1. There we go. So if I typed in -6 squared, it's going to give me -36, which is correct based off of what the calculator thinks I'm doing. Order of operations here is telling the calculator, take the 6, raise it to the second power, and then negate the result. So the calculator thinks that you want this. All right. So when you type in -6 squared, calculator thinks you want this, and that's most calculators. I can't think of any calculator that's automatically going to group things for you just because you want it to, right? Without you actually explicitly telling it. So if you want to take a negative and square it, you'd have to put it in parentheses to get that positive 36. But I think that's a lot of keystrokes for something fairly simple. Right? So if you know that the negative is going to go away, and all you have to do is worry about squaring the absolute value of the number, then just do it that way. That's probably the easier way to do it. Right? So bottom line is I'm adding 36 to both sides. Left side is now factorable as a perfect square trinomial. Right side is simplifiable. I mean, I'm only adding, so that's going to give me a 40. But remember, when we simplify a perfect square trinomial, we take the square root of the first term, we take the square root of the last term, and we carry down the sign of the middle term. So we're going to have an R, and we're going to have a 6 with a minus sign in between. All right. Now I need to solve for R here, so I'm going to take the square root of both sides. So square root on the left-hand side to get rid of that power of 2. Square root on the right-hand side because I took the square root on the left-hand side. All right. Actively taking the square root means you get a plus or minus. 40 is not a perfect square, so back to our side workstation over here. We're going to break that down using a tree diagram, or if you could do it in your head, even better. But we're going to break it down into a product of two numbers, one of which is a perfect square. So if you have to go to the table for that, go ahead. But if it's got a 4 in it, if you're looking at a number that has a 4 in it somewhere, a good place to start would be a factor of 4. All right? So, you know, there are exceptions, because 9 times 6 is 54. You know, you look at that and you say, oh, it's got a 4 in it, so 4 must go into it. And, you know, it's not always the case, but it's a good strategy, a good place to start. So 4 times 10 cannot be broken up into factors that are perfect, either of them. But square root of 4 is 2, so I can make this 2 times the square root of 10. So plus or minus 2 root 10. On the left-hand side, it's just r minus 6 now, because the power of 2 and the radical work their way out. Once you've simplified your radical, it's actually, in my opinion, it's actually nicer to have an irrational answer, because there's less to do. We don't have to break it up into two separate equations. We can leave the plus or minus there. All I'd have to do is add the 6 to both sides. So plus 6, and we get r is equal to, we always put the plus or minus part at the end. So 6 plus or minus 2 root 10. All right, and that would be our final. All right, we don't need the logical or notation because, again, the plus minus symbol is actually read as plus or minus. The or is embedded in the symbol. All right, so I don't want to cut into too much of your time. This might be good enough because the next one doesn't involve the fraction. The first one was definitely more complicated than the second one. Second one, your first step would be to divide everything by 4, and then reorganize a little bit. Well, now that I started talking about it, I feel the need to do it, only because you're going to get a fraction in that, and I want to show you how to handle that. I talked myself into it. So first move, divide by the leading coefficient. That doesn't have to be your first move, but it's got to be a move before you try to complete the square. All right, you could reorganize if you want first, but I see all of these values are divisible by 4, so I have an urge to just go for it. All right, so we have x squared equals 6 plus x. All right, now a general form of a quadratic is ax squared plus bx plus c equals 0. But our first move when we solve a quadratic using completing the square is to move the c value to the other side. So in this instance, I'm just going to subtract the x from both sides and leave the 6 where it is, because that would be the first thing I would get rid of anyway. So I'm looking at x squared minus x, leave a little space to complete the square, is equal to 6. And this is the reason why I decided to do this problem, because when you complete the square here, you're going to get a fraction, and oftentimes people get jammed up on that. In fact, when I was looking at the submissions from the other day, that's almost in every case where if somebody was making a mistake, it was usually to do with fractions. All right, so my side work. My b value is a -1 squared, geez Louise, over 2 squared is going to give you 1/4. All right, because remember, in front of that x, yeah, there's a minus sign, but there's also an assumed 1. All right, so this is really a -1x, and so that's my b value. So I have to add a quarter to both sides of the equation, so plus 1/4 plus 1/4. All right, 2 ways to simplify the right-hand side. Whenever you add a whole number and a proper fraction, right, so one where the numerator is less than the denominator, that's really the same as a mixed number. Same as 6 1/4. And we know how to convert from a mixed number to an improper fraction. You take the denominator, multiply it by the whole number, and then add it to the numerator. You know, like 4th grade, I think. So that would be 25 over 4. However, as impressive as that would be, you could also just add them on your calculator. So 6 plus alpha y equals n over d, so the fraction tool, 1/4, and it'll convert it. It'll add them and put it in simplest form, so you don't have to worry about doing it manually. Maybe you give it a shot doing it in your head and then verify in the calculator, because we always like to make sure that we didn't just make a careless error. Right? So as hard as it is to believe, on the left-hand side, we do have a perfect square trinomial, because if you carry out the side work properly, that it's guaranteed. So we take the square root of the first term, we take the square root of the last term, and we carry down the sign of the middle term. All right, so let me get my highlights where they should be. Sign of the middle term is minus, that's easy. Square root of x squared is x, we've been doing that a bunch. Square root of 1/4 is where people get jammed up. Square root of a fraction is the square root of the top divided by the square root of the bottom, or the square root of the top over the square root of the bottom. All right, so I would be looking at this as 2 separate things. I would say, give me the square root of that one, that's going to be a 1, and then take the square root of that one. You know, separately, 2 separate numerical values. Square root of 1 is 1, square root of 4 is 2. All right. It should be, it must be a perfect square, so it will be something that you could put in your calculator too, if you're ever unsure. So I would put in, I have no idea, the square root of 1/4. Or maybe it's something more complicated, like 9/16, and you're just not sure, right? But you put in the square root symbol, alpha y equals n over d. I'm going to put in the 1/4. And it'll simplify it for me, but only if it's rational, if it's a perfect square. All right, so it'll do the work for you. And we might need it again in a second, because you look at that the 25 over 4, we're going to have to take the square root of that. All right, so getting to know the features in your calculator is pretty useful, obviously. Square root of both sides. Left side, the power of 2 goes away. Right-hand side, I need a plus or minus for the fact that I am choosing to take the square root. I want the square root of 25 over 4, which would be 5 over 2, because square root of 25 is 5, square root of 4 is 2. But let's say I don't know, or I'm not comfortable, or I'm pretty sure, but I want my calculator to check. Type it in. it'll do it for you. All right, so 5/2. Now this one's rational, so we didn't have to simplify our radical, but there is a trade-off. The trade-off is that we now have to split the equation up. All right, so I'm going to add the 1/2 to both sides. So I'm going to get x is equal to 1/2 plus or minus 5/2. But split it up, we get x is equal to 1/2 minus 5/2. X is equal to 1/2 plus 5/2. Now that part should be, because it has a common denominator, should be pretty easy to do in your head. Right? 1 minus 5 is -4 divided by 2 is -2. But you could also combine into one fraction, 1 minus 5. You get -4/2, which is -2. So that's one solution. And again, just to make sure I drive this point home, you don't have to show any of this work. Once you get to this point, if you want to jump to the final answer, you can. All right? So this is just for the folks who may not quite follow along when I say, oh, just do it in your head. And you're like, oh, how nice, you know, like maybe you can't, maybe I can't do it in my head. You know, so 6/2, and you get x is equal to 3. So those are my two solutions. Don't forget the or symbol, because we broke it off from the plus or minus. Let me get rid of this calculator. And now you have a complete solution. Well, two complete solutions. Both, you know, they have their own little twist involving fractions, but they're good problems. In my mind. But first move, it's in the proper format in terms of variables being on the one side and the number being on the constant being on the other side. So I want my leading coefficient to be equal to a 1, not a 3, right? So I'm going to divide each term by that leading coefficient. So I'm not dividing by a fraction here, so that's something, I guess. So I'm going to get a q squared plus 2q, I'll leave a little space to complete the square, is equal to 2/3. Then I'll do my side work. It's the same page, it's just I changed number 2 to a different question. All right, so I take my b value, which is 2, I cut it in half and I square it, and that's going to give me a result of 1. So again, I took my b value, chop it in half, 2 divided by 2 is 1, square it, the result is 1. So that's what gets added to both sides of the equation. All right. On the left-hand side, it's a perfect square trinomial. So it's square root of the first term, square root of the last term, carry down the sign of the middle term. So q plus 1. On the right-hand side, I have to get this in a better form. Right? And you can do it with a calculator, but if you recognize that adding a whole number and a proper fraction, so what's proper fraction? Not improper fraction. The numerator is less than the denominator. This is the same as a mixed number, 1 2/3, less. So I can convert this pretty easily. You know, the old, I think it was 4th grade method. You multiply, and then you add. That gives you the new numerator. So 3 times 1 is 3, plus 2 is 5, so 5/3. Or, just put it in the calculator. I'll just do it over here. So, just use the fraction tool. Alpha, y equals n over d, 2/3 plus 1. And it'll simplify for you. All right. So now it's ready to be rooted. I'm going to take the square root of both sides. There and there. On the left-hand side, I get a q plus 1, because the power of 2 and the radical cancel each other away. But on the right-hand side, it's not quite as nice. All right? I have two numbers that make up that fraction, neither of which are perfect, and neither of which can be split up into perfect square factors. All right? The best I can do at this point is to just rewrite it as a plus or minus, but I could also split the fraction. Instead of looking at it as the square root of the fraction, I can look at it as a fraction of the square roots. So that brings us back to a skill from last week, where we were looking at the idea of having radicals in the top and bottom of a fraction. We didn't want that. All right, we want radicals only in the top or only in the bottom, if they're going to exist in a fraction at all. All right, the general consensus is that most people want them in the top of the fraction, because if you have to get a common denominator to put two fractions together, it's easier to have a rational denominator and get a common denominator that way, right? So long story short, what that means is that most people are going to rationalize the denominator rather than the numerator. So we multiply top and bottom by whatever the radical is in the denominator. You always multiply top and bottom by whatever radical you want to get rid of, right? So q plus 1 is going to be equal to plus or minus, well, the top by the top is rad 15. Rad 3 times rad 3, the bottom times the bottom, is rad 9. Square root of 9 is 3. All right, so then the only thing that remains is to get q by itself, and I would do that by subtracting the 1. And I would have q is equal to, we always put the plus or minus thing at the end, -1 plus or minus the square root of 15 over 3. Some people like to get a common denominator and make it a single fraction at this point, but that's not necessary. Not necessary. I kind of stuttered there, but it wasn't intended to be a double negative. It is not necessary. So yeah, that's the second example I wanted to go over. Both of them are a little crunchy in some capacity. They'll bring a little something different to the party, but they're manageable. You just gotta start to put together all the things that we've been learning in the unit. On the same side of the equation. So how you do that is up to you, as long as all the x's are on the same side. So as my first move, I'm just going to subtract the 24x. And I'm going to get -3x squared minus 24x. I'm going to leave a little space to complete the square, and it's going to be equal to 13. All right? But in order to complete the square, or at least using the technique that we've been using, we need to have a leading coefficient equal to 1. All right? So that tells me that I'm going to divide each term by a -3. All right? So on the left-hand side, I'm going to get x squared plus 8x. I'm still going to leave that gap. This is -13 over 3. So I'll do my side work. Taking my b value, cutting it in half, and squaring it. All right. So we're going to deal with a fraction here. You know, from a selfish standpoint, we'll be kind of lucky if the right-hand side ends up being completely negative, because that means that we would have no solution. But we have to do the b over 2 squared part first. So my b value is an 8. Eight over 2 squared. So 8 divided by 2 is 4, squared is 16. That's the number I'm adding into the gap here. And that's the number I'm adding to the right-hand side. All right. Now to simplify the left, that's going to be pretty easy, but the right, I'm combining a fraction with an integer or a whole number. I'll let the calculator do that. because the calculator handles fractions very easily. Alpha y equals n over d. Type in negative 13 over 3. Then plus 16. Hit enter. It'll give you the answer in simplified form. So 35 over 3. Right? And you didn't have to worry about a common denominator. Now, the left-hand side, again, it's a perfect square trinomial. So the square root of the first term, the square root of the last term, carry down the sign of the middle term. So x and 4, whole thing raised to the second power is equal to 35 over 3. Now I want to get x alone, so I'm going to take the square root of both sides. All right. On the left-hand side, it's just x plus 4. On the right-hand side, we're taking the square root. We decided to do that, so we have to throw in the plus or minus. But I have a radical 35 over 3 that can't be simplified any further, and it's not going to be the product of any kind of perfect square values. So the only thing I could do at this point is to split up the fraction, make it radical 35 over radical 3, and rationalize. All right. Typically, we want to rationalize the denominator, but as long as it's rationalized in some way, you'll be fine. It's just more useful in this context to rationalize the denominator. So the way we handle that, if you remember from last week, is we multiply top and bottom by the radical we're looking to get rid of. All right, I want to get rid of the radical 3, so I'm going to multiply top and bottom by radical 3. All right, so on the top, I'm looking at radical 105. On the bottom, radical 3 times radical 3 is just a 3. So I have my plus or minus there. I would look to simplify that radical 105, but I knew I couldn't break down the radical 35 because that's a product of 5 and 7. And then all I did was I multiplied that by another 3, or just by a 3. That's not going to create a perfect square anywhere. All right, so I'm not even going to bother, but you should always have a look. Okay? So now I'm going to subtract the 4 from both sides. We always, when we represent a final answer involving an irrational number, we always put the plus or minus part of it at the end of the expression. All right, so this would be x is equal to negative 4 plus or minus, I'll get this on the screen in a sec, radical 105 over 3. All right, so let me reduce a little bit here. All right, so this obviously is a lot more complicated because you have that rationalizing part of it coming into play. But it's still the same process. You want to have a leading coefficient equal to 1. You want to use your b over 2 squared. You want to factor the left, simplify the right. It's just the quality of what ends up on the right-hand side may impact the difficulty level of the problem. Right? And most of the time that has to do with simplifying the radical. Right? So